Hopefully you've looked at how we analyze univariate data, that is one data set, such as the height of adult males or the weight of adult males. In this section, we're going to begin our study of bivariate data. And for example, we're looking for a relationship between the height and weight of adult males. So our bivariate analysis is concerned with the relationships between pairs of variables, and we assign one of them our x and one of them our y, or our independent and dependent variables. The relationship between two variables is called their correlation. So data that is closely related to something has a high correlation. To examine whether or not there's correlation, we usually are going to look at a scatter plot diagram. From the table, our independent variable goes on the x-axis, our dependent variable goes on the y, and if it's a problem involving time, time is almost always going to be an independent variable. Data that follows a very clear trend is correlated. So here we have three examples of positively correlated data. In other words, as we move left to right, our data is going up and to the right in all three of these cases. And if you look, this is strong, moderate, and weak. All three of them show a positive upward to the right trending in our data, but there's much less variation in this first one. It is strongly correlated. The data is tightly packed along a trend. This one's a little bit more spread out, and this one's significantly more spread out, but still going generally up and to the left. I'd like you to pause the video right now, and I'd like you to draw three videos that are similarly correlated but in a negative direction. So I want strong negative correlation, moderate negative, and weak negative. Pause the video now and draw those. So here is strong negative correlation. That would be an example of moderate negative correlation. And something like that might be weak negative correlation. There's no one right answer for these. The big thing is that as you look left to right, these are going down and to the right. It is possible that we'd have a scatter plot that has no trend, and that's going to indicate that there's zero correlation or close to zero correlation. What that might look like is this. There's no real trend going this direction or this direction. The dots are fairly random. So these points give us no correlation. Causation is different than correlation. There may be a relationship between an independent variable and a dependent variable, but that doesn't mean that one causes the other. What we could have is something called a confounding variable. And if we look at the shoe size of a person and their vocabulary, if you collect data, you will probably find that for small shoe sizes, such as infant children, the vocabulary is very small, but if you look at adult shoe sizes, the vocabulary is big. Okay, so we see that there is a relationship, there's a correlation between those, but it doesn't mean that the shoe size causes a larger vocabulary. What's the confounding variable here? Well, the confounding variable here would be the person's age. A young person usually has small shoe size and low vocabulary, and as they get older, it's their shoe size increasing and so does their vocabulary, but it's their age, usually not their shoe size, that increases their vocabulary. So that is an example of a confounding variable, and it illustrates that correlation is different than causation. Okay, so we have an XY table here. We want to represent this data on a scatter diagram, a scatter plot, and we want to look at, is the relationship linear or nonlinear, because data can be correlated in a way that doesn't follow a linear pattern. It might be a curved correlation, and that's okay. And then we're going to identify the type and strength of this relationship, if indeed it is linear. So we should have our x and y axes, and we really only need quadrant 1. And we plot these points. So pause the video and create a very nice, clear scatter diagram on your page. So it looks like this. Is it linear? Okay, well that would be if we take a straight edge and we put a line running through the middle of the data, does it sort of follow that line? Are some points above, some points below? Or does it follow more of a curved pattern? And in this one, it is linear. And what type or strength of this relationship is there? Well, it's positive. And I'd say it's moderate. Later on in one of these sections, we'll look at how to more precisely define this, but I'm calling it moderate because some of these points are a little bit far away from this line that I drew in, but in general, they're pretty tightly packed, resembling this line. So we've reached the end of this section. You should be able to identify what data has correlation and which doesn't, and also be able to classify it into strong, moderate, weak, positive, and negative, or no correlation whatsoever.